Hi everyone, welcome to another episode. Today we're going to be trying to fix this Emerson Liebert Powersure UPS, which I think may just be the power button has gone squished, but yeah, most likely a dead battery as well. So we're going to have a look at that one. Right, here we have it. I believe there's just 4 screws to get into this. Before I do this, I must stress to anyone thinking of doing this, this can be incredibly dangerous on the inside. There's potentially 230 volts present. There could be charged caps if the discharge resistors have gone bad, so you must take precautions with this. Don't go into these unless you know what you're doing. Yeah, so I'm going to crack on. I will get my long screwdriver because my normal electric's not going to fit in there. Right, which size are we? Let's try that one first. It should open up. Right, there we are. So we've got the big battery, that's most likely flat, I would have thought. That's network protection. Might just need a clean actually, it's been in quite a dusty environment, this one. Is the fuse in? It's in, yeah. Right, let's start by getting this out the way. I don't think this is going to have an ounce of charge in it. It's not bulging. Maybe slightly there. Let's take this off. See what I mean about dusty? Alright, meter. This is going to be dead, I would have thought. I've got the leads the wrong way around. Yeah, 2.6 volts. That's knackered, I would have thought. I think that's had it. I think our battery might actually be open circuit. So it did read 2 volts, didn't it? It's reading 2 volts now. So when I put that across it, that actually pulls the voltage down to 0. Wow, ouch. I'm going to leave that sat there and see if it does anything at all. It might just be completely dry. And if one of the cells has gone, then it's not going to recover, as I suspect is probably the case. So in here we have a board. So there's the brain, that's going to be on the low voltage side. And we've got various mains wires. Plug this in, off, on, and turn this off. Black and red. Let's turn the current down. 0.5 amp to see if anything happens. Nada, zilch. Ah, it's doing something. I think it might just be the switch, you know. Right, there might be some high voltage on this now, so just be careful. So that's snapped in there, it ain't coming out, is it? Bit of force, there we go. Alright, so let's fill this full of contact in there. So I may have done a full unnecessary electrical inspection. Something we learned when I was doing call systems is you get corrosion on the surface of the contact, so just like a gentle sharp tap can help clear it. I used to get it on nurse call buttons. They stopped working. You just put some switch cleaner in, give them a sharp tap, and they'd start working again perfectly. Okay, we'll let that dry out for a bit, and I'll come back and put some mains on it again and see if it actually does anything. It probably is just this. Just rub some light over here, get all the dust out of it. I could even put a tiny bit of silicone grease on it, it slides through more easily. I've got loads of that for repairing cassette decks and the like. You grease up the plastic gears with silicone grease. Okay, so it's good that we've done an electrical inspection anyway. I've found a couple of bad bits. So these cracked joints, I want to go over these. I might remove the unleaded actually and just replace it with leaded, because it's leaded is more flexible, it tends to last longer and things like this. Right, I'll see you in a bit. So it's a tiny bit of silicone grease. This is stuff used in tape decks and the like. A pop. There's some little tiny spots in here. Plenty. Put that back right up out the way. Get him the right way up. Now pop that back in. Whoops, boing. Still not. Still not actioning correctly. There's no click. So there's something funny about this switch. it works fine there. Tell you what, for now I'm just going to pop that out. Wonder why that's not working. I think the travel on the switch has changed slightly and it's not quite how it's meant to be. Now I'm going to be actually using this here. This doesn't go out into the wild, so I don't have an issue with just putting my finger in there to do that. You've got pretty damn good isolation. This is a low voltage circuit anyway, and it's a plastic plunger, so I'm not too bothered about that. If it was going out into the wild, I'd change the switch, but I'm not. This is going to be used here for my PC. Oh, I just got to figure out how the hell it went in there. Ah, right, so that goes the other way around. Get him out again. I should see, really, shouldn't I? Because the connector's pointing down into the unit. Silly me. Right. So that goes into there. That wire brushes past that cap. Well, this is strange. That goes over there. So there's some screws in it, really. Goes that way up, like that. Put the earth back. Let's probably pull that out. It's unplugged anyway. That one out. And in you go. Right, we'll get some ties and tidy this up a bit. So basically all I need is a new battery. So I'll get on and order that. And I'll continue this when I've got it and you can see it all working. Okay, a few days later, I've already zip tied everything back up. Put those back in. New battery. So high rate, super duper battery apparently. Yeah, I've already checked this for magic smoke and we're looking good. I'm going to plot this one in here. Good thing to do when you get a new battery is just put a meter across it and make sure it's above 12 volts. If it's under that, it's probably been sitting around for a really long time and is best sending back. That one on there. This is going to do a nice big spark. Oh, no, we're alright. This scares the hell out of me, that does. That one in there. And if I put that on, making its beepy noises, and it's producing AC. If I plug it in, dunk, back onto standard power. So all looking all good. Tick. Let's get the meter out actually. I'll just give you a quick, show you quickly. So we have got, be careful because he's plugged in. It's going to be negative, I've got them the wrong way around. On volts, aren't we? Yep. 17.7ish, that's its float voltage. So it does go up slightly when it's charging, and it this one disconnects when it's charged. So it just keeps it floating at a certain voltage. Once it dips, it just tops it back up again. So I'm going to put the screws back in and give it a try. And there we have it, back in one piece. Now he's got the switch there, so the cap's missing. There's probably something wrong with the switch a little bit, so it's where it springs back has become slightly damaged, but it still ticks away nicely when you press the button. So I guess the next check is to stick a load across it and see what happens. Okay, so I've got it plugged in. It's currently powering my tower PC. So just for reference, that's a Ryzen 5 3600, 32 gigs of RAM. There's currently one external hard disk plugged in and an external SSD plugged in. It's running two 2.5 gig LANs, and there is a RTX 3060 which currently has load put on it. So I'm just going to pull the plug on this. I've put the USB cable in, that's the blue one. And it's holding up nicely. All in all, I think that one's a fix. So if you like the look of this video, there's plenty more. Please do like and subscribe, it really helps out the channel, because we're just a baby at the moment. So it could do some more subscribers, some more views, but in the meantime I will keep plugging at it, and see you on the next one. Cheers.